Hello guys, in this lecture we are going to talk about one of the most important feature transformation methods, which is PCA. Principal component analysis is a common way of speeding up a machine learning algorithm. If your learning algorithm is too slow because the input dimension is too high, then using PCA to speed it up can be an excellent choice. This is probably the most common application of PCA. Another common application of PCA is for data visualization. In our breast cancer example, we have only 9 features and 286 rows, so we don't need to speed up our machine learning model. In fact, using PCA on our example will lead to a great loss of accuracy, because PCA will compress our features, which will lead to a great loss in data, as we will discuss later in this video. But we want to visualize our dataset, which is impossible in the current form, because 9 features mean 9 dimensions, and that is very hard to plot. So what we will do is to reduce that 9 dimensions into 2 or 3 dimensions, so that we can plot it and hopefully understand the data better. Now let's plot a 2D visualization of our dataset. First, let's import Matplot and PCA libraries. Then, let's create a PCA object. After that, we will fit transform our features. Now let's create a target names array. After that, we will create a colors array for the colors we want in our plot. Now let's draw our dataset features. The first parameter in BLT scatter is our first feature. And the second parameter is our second feature. The third parameter color is our color array. Alpha represents the blending of our colors, and it takes values between 0 and 1. LW is the size of the point, and the last parameter label is our target names. Now let's give our plot a title. We see now how we managed to plot our dataset. Now let's draw a 3D visualization of our dataset. First, we will create a PCA object and set the component to 3. After that, we will fit transform our features. Now let's import X3D library to plot our 3D dataset. Now we will set our figure size and set our projection to 3D. After that, we will draw our features point, same as we did before. And the only difference is that the third parameter is now our third feature. We see now how we managed to draw our dataset in 3D Bloat. Now we will talk about explained variance, which is a very important thing to look at when you use PCA, because it tells us how much information can be attributed to each of the principal components. This is important as while you can convert 9-dimensional space to 2-dimensional space, you will lose some of the information when you do this. By using the attribute explained variance ratio, we can see that the first principal component contains about 60% of the variance, and the second one contains 13% of the variance, and the last one contains 11% of the variance. Together, the three component contains about 40% of the variance, which is very bad in our case. So in this particular example, we shouldn't use PCA, because it will make us lose most of the information we have. That's it for today's video, and see you in the next one.